Last episode, we decided the truth is what happened, not what is. So here is the whole storage layer. One table, one operation. You append and you read. There is no update and there is no delete. And that is not a discipline the team agrees to follow. It is a permission the database does not grant. Everything else in this series is derived from that one constraint. It sounds austere, and it is. And the austerity is the point. A system where the past cannot be edited answers questions that a system where it can be edited simply cannot, no matter how careful everybody is. An event is a fact about the past, and its shape follows from that. It has a stream, which is the thing it happened to, usually an account or an order. It has a sequence number within that stream, because ordering is the whole meaning. Deposit, then withdraw is a different life from withdraw, then deposit. It has a type, a payload, and the metadata that makes it auditable, which means who caused it and what request they were in. And notice what is not there. There is no ID that lets you find and change it later, because you are never going to change it. The row is written once and read forever. Now the naming, which sounds like pedantry and is not. Events are named in the past tense because they describe something that already happened and cannot be argued with. Money deposited, not deposit. Order shipped, not ship order. That distinction separates two things. People constantly blur. A command is a request that can be rejected, and an event is a fact that cannot. Get this wrong, and your log fills with things like update balance, which is not a fact about the world. It is an instruction to a database, and now you have written your implementation into your permanent record. In 5 years, the implementation will be gone, and the events will still be here. Name them for what the business did, not for what the code was going to do about it. So if the balance is not stored, where does it come from? You calculate it. Start from nothing, walk the events in order, and apply each one to what you have so far. Deposit adds, withdrawal subtracts, fee subtracts. That is a fold, and it is the same operation you have written 100 times without a fancy name. The important property is that it is deterministic. The same events in the same order always produce the same balance, which means state is not something you protect. It is something you can throw away and recompute whenever you like. And that turns out to be the most useful property in the whole pattern, for reasons that get an entire episode later on. And here is a consequence that catches people pleasantly. If every piece of state in the system is derived from the log, then the log is the only thing that matters. Your read models, your caches, your search indexes, your reporting tables, all of it is disposable because all of it can be rebuilt. So your backup strategy collapses to one sentence. Protect the events. Lose a projection and you rebuild it before lunch. Lose the event store and you have lost the company. That clarity is worth something on its own because most architectures cannot tell you which of their 30 tables actually matter. And here, the answer is one table, and everyone knows it. Which brings us to the objection you have been holding since the first minute. Folding the whole log to show a balance is fine with 12 events. This account has 40 million, and the page has to render in 200 milliseconds. Next episode, projections, read models, and how you get an answer without reading history every time. See you there.